In today's notes video, we're going to be revisiting the topic of inverses and expanding it to exponential and logarithmic functions. To help us kind of understand how exponential and logs work with inverses, we are going to start by graphing some inverses. The first thing that I'm going to do here is create a table using the x values -2, -1, 0, 1, 2, 3, and graphing the function y equals 2 to the x. So I'm going to draw a table. And I'm going to plug each of these x values into my equation right there. Take a second to do that on your own. Now that I have my x and y values that go along with the function y equals 2 to the x power, I'm going to go ahead and plot those points on the graph I have here. Take a second to do this on your own. The graph you drew should have looked something like this. Remember that we do have an asymptote on our exponential functions, and if you struggle with creating the points in a table, you can always graph this in your calculator and go from there. The next thing we're going to do is find the inverse of this graph. Now, as you may remember, an inverse is when we switch the x and y values of the coordinates. So remember, inverse means to switch x and y. I don't know why I put the y so close to the and. So I'm going to flip my table to get my new coordinates to plot. So I would have 0.25, -2, 0.5, -1, 1, 0, 2, 1, 4, 2, and 8, 3. Take a second to plot those new coordinate points on your graph. Now that I've plotted my points, I see that these two functions appear as though they have been reflected across the line y equals x. Flipping those x and y coordinates has created a mirror image across the line y equals x, and we're able to see our inverse. Now, we don't really see many functions that are graphed like this, and we're going to try and figure out what kind of function that is by finding the inverse of y equals 2 to the x power algebraically. So to find the inverse of something algebraically, we need to switch x and y. So x equals 2 to the y power. So we switch x and y. Next, we need to solve for y. Looking at this, there's no way to get the y by itself by dividing. I can't multiply. I can't subtract anything. And I can't take the square root because 2 and y are connected. 2 is raised to the power of y. The only way that we can get the y out of our exponent is if we turn this into a log. So normally when we're turning something from exponential form to log form, we have the base to a power equals an amount. So a base to an exponent equals a number. All I did was flip which side of the equals mark that is on, so it's easier for me to write this as a log. When I switch this into log form, I have to remember that logs are bay. I have a base, an exponent, and an amount. The 2 goes at the bottom of my log. The x comes beside my log, and it's equal to y. All it took was for us to take the log of our exponential to get the y by itself. And so our final step, we need to write it as f negative 1 of x. So f negative 1 of x equals log base 2 of x. And I want you guys to see what happens when we type that into our calculator. So I'm going to pull Desmos up. When I go to functions, remember, we type on miscellaneous, and that pulls up log a that we can use. So I just typed log a. 2 goes at the bottom, and x goes in my parentheses. Doesn't that function match the one that we got in our graph here? Exactly. So an exponential and logarithmic functions are inverses. So I'm going to write this down all the way down here just for you guys to remember if you like to write things down. So exponentials and logarithms are inverses of each other. Exponentials and logarithms are inverses of each other. Now, we're going to go to the next page of your notes, and we are going to find the inverse of a couple different problems algebraically. Up at the top of the page, we have a few different steps. We have steps of how to find the inverse of exponential functions, and these are the very same as what we've done before. These use the BPN method. You can also think about this in our Bay method. So we can also say B, A, E, and switch this to E equals log base B of A. So if you would rather use your Bay method, you can write it out like that. Same thing with down here, B, A, E, and we can rewrite it as B to the E power equals A. So we have steps that you can follow for inverse of an exponential or inverse of a logarithmic function. We're going to do a couple examples together on how to do each of those. So to find the inverse of an exponential function, the first thing that I need to do is replace f of x with y. So step 1, y equals 5 to the x power. Step 2 is to switch x and y. Now, if you need to rewrite this, you guys are welcome to. So I like to rewrite it and just flip what side of the equal marks we're on. So 5 to the y power equals x, and I'm going to identify base, my exponent, and then the amount that I have. From there, I need to rewrite this. And that is really the first big step where we're starting to see this change. And that's why I'm going to change colors. I need to put this exponential into log form. Log base 5 of x equals y. Looking at what I have there, the y is by itself, so all I have to do is my final step to replace this with f to the negative 1 of x equals log base 5 of x. Not too bad. It's just figuring out when you need to make that switch and remembering what pieces go where. We're going to go ahead and try number 2, And number 2 has something extra special going on with it because we notice that there's something extra in the exponent. Now, since this plus 4 is up in the exponent, we're going to leave it how it is. So I'm going to start off, step 1 is to replace that g of x with y. So y equals x to the plus 4 power. Step 2 is to switch my x and y. Now x equals 3 to the y plus 4 power. Now, even though we have this plus 4 there, and normally we would try and move things around to make the y get by itself, the first thing that we're going to need to do is to switch this into log form. And the reason for that is we can't move that 4 while it's up in the exponent. So I'm going to come down here, and I'm going to rewrite it so that the y, 3 to the y plus 4, is first and the x is second, just because that makes writing everything in log form a little easier. I have my base, I have my exponent, and I have the amount at the end. So we're going to go ahead and switch this into our log form. Log base 3 of x equals y plus 4. Now, we're not quite done because we have to solve for the y and get it by itself. So to do that, I'm going to subtract 4 from each side. Now, this is super important and will completely change your answer. When I do this, log base 3, the x is going to go in parentheses. We are only taking the log of the x, and the minus 4 comes afterwards. The minus 4 doesn't fall in with the log. We would want it to be separate. So now that I've subtracted 4 from each side, I can write out my log using g to the negative 1 of x equals log base 3 of x minus 4. Remember, the 4 does not end up inside of that log simply because we took the log before we moved the 4 over. The 4 is sort of kind of late to the party. It doesn't get to get in. Finally, we're going to go the other way. So to go the other way, we are going to take a log and we are going to switch the log into exponential form. Because remember, the inverse of a log is an exponential. So to solve each of these, the first thing that I'm going to do, step 1, is to replace p of x, and it could be any number out front. It doesn't matter what that number is, it always means, or what that letter is, it always means the same thing. So I'm going to change that to y equals log base 7 of x. Step 2 is to switch my x and y. So x equals log base 7 of y. Now, some people, like I've said before, they like to go ahead and put that back into the order that we're used to, where the log comes first and the amount's on the other side. Once we've done that, we need to find out what our base, our amount, and our exponent is. So I'm going to label this because logs are BAE. Remember, B-A-E. Our next step is to rewrite this using our exponential form. Because when we're at this point, we can't get the y by itself any other way because it's impossible to divide by a log. The only way to get away from a log is to switch it into exponential form. So 7 is my base. My exponent is x, and it equals y. Remember, whenever you switch something into log form when we're dealing with when we're dealing with inverses, we normally want that y to come out by itself. My y is all alone, so my final step is to replace the y with p to the negative 1 of x equals 7 to the x power. Finally, we're going to work one more example, and we're going to look at number 4. The first step that I need to do is I need to replace that h of x with a y. So y equals log base 2 of x minus 3. Second step is I need to switch x and y. Now, looking here, I have something I need to take care of before I can worry about switching this over. Even though there aren't any parentheses around that y, we can only assume that the y is part of the log. Since this minus 3 is not in parentheses marks, we can't assume that that minus 3 is part of the log. So we're going to have to move this minus 3 over because it's not attached. The only time that we wouldn't move the minus 3 over is if there were parentheses around the minus 3. Otherwise, we've got to move that 3 before we can start to label things. That leaves me with x plus 3 equals log base 2 of y. I know that looks a little messy, but it's going to work out the way it's supposed to in the end. Our next step, we're going to need to figure out how to be able to switch this over, because we're at the point where our y can't be pulled out by itself without using our exponential form. Log base 2 of y equals x plus 3. And like I said before, you don't have to switch this around and rewrite it. The only reason that I did is because we're used to dealing with logs in a form of a log of something equals this. So I just flipped it around so it's easier for you to remember where our labels go. So I have b, a, and all of x plus 3 is our e, or our exponent. My step 4 is now I'm going to switch that into exponential form. The base is 2. My exponent is x plus 3. And that is going to equal y. Since the y is all by itself and I don't have to move anything around, all I have to do is replace the y with h negative 1 of x equals 2 to the x plus 3 power. Now, if you guys take 1 second to notice, and this is just one important thing I want to point out. That problem number 1 looks a lot like the answer to number 3. The answer to problem number 1 looks a lot like the answer to number 3. The same thing happens with problem number 2. The problem number 2 looks a lot like the answer for number 4. And the answer for number 2 looks a lot like the problem for number 4. These are going to follow very similar setups, and you'll start to recognize some patterns with the more practice that you guys do. Please let me know if you have any questions in regards to inverses for exponential or logarithmic equations. Remember, anytime you find the inverse of an exponential function, it will turn into a log. And anytime you find the inverse of a logarithmic function, your inverse will be an exponential function.